Okay, so earlier in the chapter, you will remember, or maybe not, but it was on page 487 when we're first introduced to the equilibrium constant. I did not mention it in that video because the temperature was not discussed in more detail until later in the chapter. So I'm telling you now. But the pink box on page 487 says the value of the equilibrium constant for a given reaction changes with temperature. Now, at this level of chemistry, you're not going to have to calculate that difference. What we're learning here is a general relationship, a general concept, okay? And so the pink box on page 500 says when temperature is raised, an equilibrium will shift away from the side that contains energy. And when temperature is lowered, it will shift towards the side that contains energy. Well, we have to go back to a concept from a couple chapters ago, and that was the enthalpy change, all right? If you'll remember, the enthalpy change was the change in energy, which was heat, right? And so we learned that delta H, that is less than 0, okay, that's going to be exothermic. Okay, and what that means is that is when heat is released. So when you do a reaction and the bottle heats up, then that's going to be an exothermic reaction because that's releasing heat as it happens. All right, and when we have a delta H of greater than 0, it's going to be endothermic. So what that means is as you see the reaction progress, it actually will make something colder. It absorbs heat. Okay, it requires heat to be added to the reaction, to the reactants in order to make the products, okay? So remember these concepts. If you don't, that's fine. Write them down, remember them again. And these are gonna be important for understanding the relationship that temperature has to Le Chatelier's principle, which again, all Le Chatelier's principle tells us is that if a reactant or product is added to a reaction that's already in equilibrium, it's gonna shift it's gonna change the equilibrium constant. Okay, so when we remember these relationships with the delta H, and I'm going to leave them up here because we'll be able to refer to these when we're doing this first example. All right, so all I'm doing is moving these up so we have them up here to draw from. All right, so another way to say this, as far as applying it to this principle, when it's exothermic, that means energy is a product. If you're writing it in an equation, and if it's greater than 0, then energy is going to be a reactant. Okay, these are important to know. If the delta H, if delta H is a negative number, then the energy is going to be added to the product side of the reaction. If delta H is a positive number, then it's going to be added as a reactant, okay? So if we look at example 16.6, we have a delta H of minus 92.5 kilojoules, okay? And our reaction is PCl3 plus Cl2, and we have both arrows because it's equilibrium, as all these are, PCl5 gas. All right, so you see it's already a balanced equation. Like I said, we're not going to have to balance these equations. The question is, what happens to the concentration of the PCl5, okay, as the temperature is increased? Okay, so we have a delta H that's less than 0. So that means it's exothermic. That means the energy is a product. All right, so what we would do is we add the energy to the product side. Okay, so now we have PCl3 plus Cl2 yields PCl5 plus 92.5 kilojoules. Okay, and so the question says, what happens to the concentration of this product when the temperature is increased? Well, if the temperature is increased, then we are adding energy. All right, we're adding energy if the temperature is increased. If we are adding energy, energy is a product. So if we are adding a product, then according to Le Chatelier's principle, then that means we're going to shift the reaction back towards the reactants. So if we are adding energy, that means we are going to decrease the PCl5 because now we've shifted the reaction back towards the reactants. So the concentration of PCl5 will decrease as we increase the temperature because we added a product to the equation. I will end this video here.